Find and draw the maximum possible number of trees for the network shown in figure below. So electrical circuit is given, network is given. So there are two independent sources. One is a dependent source, one is a resistor. Here also resistor. Voltage across this element is 1 ohm is a Vx, and this dependent source depends on the voltage. Dependent voltage source depend on the voltage. So this is the circuit given or network given. So first we have to identify the nodes. So there are 4 nodes A, B, C, D, and the number of branches are 1, 2, 3, 4, 5. So 5 branches are there. So first we have to draw to get maximum number of possible trees. First we have to draw a oriented graph for the given circuit. So this is the oriented graph. So A, B, C, D are the nodes and 5 branches, and giving directions to the branches is oriented graph. So 4 nodes A, B, C, D are the nodes and 5 branches, and directions of the branches is oriented graph. So from oriented graph we can get complete or augmented incidence matrix. So augmented or incidence matrix defines the oriented graph. So number of rows is number of nodes A, B, C, D, 4 nodes, 4 rows. We get here in this matrix we get 4 rows, and number of columns is number of branches. So here in this example there are 5 branches, so I get 5 columns, and this incidence matrix is represented with AI. So here we have to fill column wise. So first branch is connected between A and B, so that's why A and B are non-zeros and C and D are zeros, and it is leaving at A and coming to B, so that's why A is plus 1 and B is minus 1. So similarly second branch is connected between B and C, so that's why B and C becomes non-zero elements, and remaining are zeros. So B and C are non-zero and A and D are zeros. It is leaving at B and coming to C, that's why B is plus 1 and C is minus 1. So B is plus 1 and C is minus 1. In similar manner we have to fill third column, fourth column and fifth column. So if you remove any row, that becomes a reduced incidence matrix, which is denoted with a capital A. So in general we remove a last row. So the reduced incidence matrix assuming node D as a reference, so you get a matrix A as a 3 by 5 matrix. Now so number of possible trees of a graph equal to determinant of A into A transpose. So A into A transpose is 2, minus 1, 0, minus 1, 3, minus 1, 0, minus 1, 2, which is a 3 by 3 matrix. So if you find the determinant of this matrix, you get 8. So therefore, the number of possible trees of a given graph is 8. So here we get 8 trees. So that all the 8 trees are this. So the possible trees are, so this is one tree, second one, third one, fourth one, fifth one, sixth one, seventh one and eighth one. So these are the all possible trees of a graph, so of the oriented graph. So here tree means we have to connect all the, there should be a path from one node to any other node, and here there is a path from one node to any other node and there is no closed path. So it is a tree. So there are many trees here. So here number of possible trees are 8. So 1, 2, 3, 4, 5, 6 and 7 and 8. So these are all possible trees for the graph.